to teach you about the subtopic in physics quantum topics, which is energy and power of photon. So, in this subtopic, you have two important things that you have to know, which is the energy of photon and power of photon. So, the first thing, let's look at the energy of a photon. As you can see here, the equation of energy of photon is E, which is energy, and H, which is the Planck constant, and F, the light wave frequency. So, let me label it, which is E is the energy, H, which is the Planck constant, and F is the light wave frequency. So, from this equation, we can expand it into E is equal to H C over lambda. So, how we get C over lambda here? So, let's look at here. As we know from F, which is light wave frequency, is equal to F is equal to C over lambda. As we know, which is C is the speed of light in vacuum, and this is the wavelength of the light. So from E is equal to HF, so we can substitute F to C over lambda. So we get the E is equal to HC over lambda. So we get the equation for energy of photon. So let's look at the second point, which is power of photon. Power of photon is amount of energy transferred in second. So to transfer a photon, we need energy. Because of that, we need the equation from energy to get the power of photon. So let's look at the equation of power of photon. As you can see here, P is equal to NHF. So what is P? P is the power of photon. N is equal to photon per second. H is the Planck constant. And F is equal to light wave frequency. So, same goes to energy of photon. We can expand the frequency equation, which is we can substitute C over lambda into here. So then we get the power of photon is equal to NHC over lambda. So now we know the equation for energy and the power of photon. So we got the main equation for this subtopic. Okay, so now we're gonna look at for the first question, which is I have prepared for you. So let's read it loud together. So a 50-watt lamp emits red light with a wavelength of lambda 7.0 exponential of -7 meter. How many photons are emitted per second? So the first thing we have to know the main question, which is what the question want me to solve. So as you can see here, how many photons are emitted per second? So photons per second. So what is photon per second? Photon per second, as we know from the previous lesson, photons per second is n. So we want what is n? So we want to find the n. So the second thing we have to know is what the important thing they have given to us from the question. So let's get through it again together. So a 50-watt lamp. So the 50 watt, we know 50 watt is the power. So we can list it together here. So I will list or write it here as the thing that given from the question. So I will write this as P, which is power, is equal to 50 watt. Okay, then we go through again. Again, emit red light with a wavelength of 7.0 - 7 meter, which is wavelength. I can write it here as lambda is equal to 7.0 exponential of -7 meter. So, from the equation, we know that the power equation from the previous lesson. So, we can solve it together. So again, so we want N is equal to what? Since we get the important thing is P is equal to 50 watt. Lambda, which is the wavelength, is 7.0 exponential of -7 meter. So, the third thing, we have to know the equation. So, do you guys still remember the equation of power? As we recall from the previous lesson that I have teach you, so we get P is equal to NHF. So as you can see here, we didn't have F, but we have lambda as the thing that are given to us. So what should we do? So as you can remember, which is F is equal to C over lambda. So from this equation, we can expand it as P is equal to NHC over lambda. So we're gonna rearrange the equation because we want to get the N, this N. So we're gonna leave it alone. So I'm gonna rearrange the equation. So we get N P lambda is over to HC. So now we have P. Yes, we get P. Lambda. Yes, we get lambda. H. Yes, we get because it is the Planck constant. And then C also we get the value because it is the constant. So we can substitute the value. So P is equal to 50. Lambda is 7.0 exponential of -7 meter. I'm sorry, I'm gonna put the units. So over H, we get the Planck constant, which is 6.63 exponential to 4 joule seconds, and then C, the speed of light in vacuum, which is 3.00 exponential of 8 meter per second. So we can calculate it. As the answer, we get 1.76 exponential of 20 per second. So this is the answer. We got N is equal to 1.76 exponential of 20 per second.